Hi. In previous talks, we've looked at installing Duende IdentityServer to work with in-memory stores. In this talk, we'll see how to use Duende IdentityServer with Entity Framework and also with ASP.NET Identity. My name is Kevin Jones from Rock Solid Knowledge. So as we said previously, we looked at installing Duende IdentityServer and used in-memory stores. We wrote an API client, and we also wrote a web client. Both of these clients needed authorization, and with the web client, we had to authenticate a user. We also wrote the web client so that it called the API client with the user's access token. In this talk, we'll have the same setup, but Duende IdentityServer will now use Entity Framework stores rather than in-memory stores. Also previously, our users were hard-coded. We stored them in memory. We need some way to manage users. And the way we are going to do that is to use ASP.NET Identity. And we'll use the ASP.NET Identity user store, and we'll see how Duende IdentityServer lets us do that. Okay, so let's dive in and write some code. So this is the code from the previous project. So here we're using in-memory users, and we're also using things like in-memory clients, API resources, and scopes, and all the things that IdentityServer needs. So what we'll do here is rather than using these in-memory stores, we'll use Entity Framework instead. So initially, I'll get rid of everything that's in memory apart from the test users. And then a little later, we'll come back and remove those as well. So to do this, we're going to use Entity Framework. And to use Entity Framework, I need to add some new packages to this project. So in NuGet, I want to add the Duende IdentityServer Entity Framework package. And I also need to add 3 other packages. I need the Microsoft ASP.NET Core Identity Entity Framework Core. I need the Diagnostics package. I want the Microsoft Entity Framework Core Tools package. And for this demonstration, we're going to use SQLite. So I need the Entity Framework Core SQLite package. So to connect to the database, we'll need a connection string. And we add connection strings into our app settings file. So here, if I open up appsettings.json, we can add a connection strings entry. We'll call this default connection. And this will be our SQLite connection string, which looks like this. So for SQLite, for the connection string, we just specify the name of the database. And we'll see in a moment how we create this database on the system. So now in my code, I'm going to get rid of all of the in-memory stores, apart from the test users. And as I've said, we will get rid of those a little later on. So we've added our connection string into the app settings, and I'll need to use that connection string in my code. And to do that, we need to get hold of the configuration in code. And the way we do that in C#6 in program.cs is by accessing the configuration through the builder. So here I can say something like var configuration equals builder.configuration. And then once I have the configuration, I can get at the connection string. So we can say var connection string equals configuration dot get connection string, and we pass it the name of the connection string, which in our case was default connection. And then once I have the connection string, we can configure the DB contexts that IdentityServer needs to use Entity Framework. So for IdentityServer, we need to configure 2 separate stores that are used by IdentityServer. One called the configuration store and one called the operational store. And we do that as part of the call to add IdentityServer. So on here, the first thing we do is call add configuration store. And add configuration store is an extension method, and this comes in the Duende Entity Framework package. This takes an options, and we use this to configure the store. So here we can say options.configure DB context to set up the DB context for this store. And again, this takes a lambda. So this Lambda takes a builder, something of type DB context options builder. And on this builder, we can say use SQLite, which is the extension method provided by the SQLite entity framework package. And use SQLite takes a connection string, and that's the value we recovered from the configuration. And then it takes another Lambda that we can configure. So when we build these stores, we'll be using migrations. And the Lambda here tells this code which assembly contains those migrations. So to get that assembly, I'm going to add code which looks something like this. We declare a variable called migrations assembly, and to that we pass the type of one of the classes we use within this assembly, and based on that type we can then get the name of the assembly. So when I call use SQLite here, we can say options goes to an opt.migrations assembly, and then to this we pass the name of the assembly that will contain the migrations. And these are migrations that are defined by IdentityServer. So specifying the assemblies this way is optional. However, if you don't specify the assemblies like this, you may see this error. And this just says basically that Entity Framework can't find the migrations when it's trying to run them. If you do see the error, then simply add the code that we've just seen. So as well as adding the configuration store, we also add the operational store. And the code for this is the same. So to this, we configure SQLite with the connection string, and again, we tell it which assembly will contain the migrations. So now that we have this in place, we can create these migrations, and then we can run the migrations to create this database. And we'll do that from the command line. So I need to generate two sets of migrations initially. We need to generate migrations for the operational store, and we need to generate migrations for the configuration store. So let's first do this for the configuration store. So that looks like this. We're going to run .NET EF migrations, and we'll add the migration. The name here, initial identity server migration, is the name of the file that's generated to hold these migrations. And then we specify the type of the context, and that's going to be the configuration DB context. And again, that context is defined by Duende IdentityServer. So when we run this, it builds the code and generates the migrations. And then we can do the same for the operational store. In that case, the DB context we need is called the persisted grant DB context. Again, it will try and build the code and create the migrations. And if I look inside my IDE, we now have a migrations directory. And inside here, we have two migrations. We have the persisted grant migrations with this name initial identity server migrations, and we have the configuration migrations with the same name, but in a slightly different location. Once I have those, I can run those migrations to create my database and to update my database. We have two sets of migrations. So we run this command twice. So .NET EF database update first with a persisted grant DB context. In fact, the order doesn't matter. And then with the configuration DB context. So now inside my IDE, we can see we have this database, IdentityServer.db. Rider comes with a database viewer. And if I drag this file into the viewer and open this up, we can see the identity server tables. So we have the various resource tables, the client tables, and everything else that Duende IdentityServer requires. So if I now run IdentityServer and browse to the discovery document, and sure enough, we get the discovery information listed. But again, notice there are things like no claims listed here. So while we now have the database, we don't yet have the data in the database. So let's go and do that now. We now need to seed this database with the data that we need. So in the previous videos, we talked about using the Duende templates. And one of those templates lets us create an instance of Duende IdentityServer that uses Entity Framework. And there's code in there to seed the databases. And rather than writing that code from scratch, I'm going to borrow that code from the template. That's in a file called seeddata.cs, which I've copied into the project. And that file looks like this. It has an ensure seed data method that takes a reference to the application we create in program.cs. And that calls a helper method, also called ensure seed data, that seeds the database with the data from our config file. So the same data that we used previously. So to use this, I need to make a couple of changes. Notice, first of all, it's using a log variable here. And this is the serilog logger. So to get this to compile, I need to add serilog into the project. And we can do that through NuGet. And I want the serilog ASP.NET core package. So we can add that. So this code now compiles. So first of all, to use this code, I need to make some changes to program.cs. And in here, I want to do a couple of things. I want to set up serilog, and then I want to change the code. So somebody passes the flag /seed on the command line, we seed the database rather than running IdentityServer. So to set up serilog first, I want to do this. I want to say builder.host.use_serilog. And this takes a lambda that has two parameters. It has a context and a logger configuration. And we use the logger configuration to configure serilog. And that code looks like this. Now, normally you'd get this configuration from the app settings file. Here, I'm just going to hard code it. It just makes my life slightly easier. I'm also going to configure program.cs to use serilog. And I'm going to do that by at the top of this file, creating a new logger configuration, and then it's logging out an information message saying we're starting up. Okay, once I have that in place, before I call app.run here, I want to check to see if the seed flag has been passed on the command line. And if it has, we can see the database. And if not, we can just run as normal. And the code to do that just looks like this. So we check to see if the arguments contain /seed. If it does, we'll log out that we're seeding the database. We then call ensure seed data on the seed data static method, passing it the application we created from the builder. And then we log out that we are done. And then we return before we can call app.run. So currently my seed data seeds the clients. It seeds any identity resources. It seeds any API scopes. And I've also changed this so it also seeds the API resources. Now remember, this data is held in this config.cs file. And again, this file is a hangover from the previous talk where we configured these stores to be in memory. So the data will be exactly the same. So to seed the database, if I go back to my terminal window, and then we execute .NET run, the application is called IDS, and that's in the bin debug net 6.0 directory in this case, and we pass it the command line flag /seed. So we run this, and notice I get my starting up message now. And our database has now been populated. So if I go back into my IDE and do, for example, select star from API resources, say, then we can see we have the weather API resource defined in the database. If I go back to the OpenID configuration endpoint and refresh, then we can now see this has been updated. So for example, in here now we have our set of scopes that are now supported, including weather API.read and weather API.write. So now we have everything in the database apart from the users. And to do that, we are going to use ASP.NET Identity. So let's do that now. So at the moment, we have our users in memory, and we want to move those to the database. Now, as we're using ASP.NET, there's a standard way of managing users called ASP.NET Identity. An IdentityServer will work with that. So to do that, we need to add ASP.NET Identity to the project. We need to create a DB context for ASP.NET Identity. We need to create migrations for ASP.NET Identity, apply those migrations to the database, and then we can also see the database with our users. Once we've done that, we also need to update our Quick Start UI. At the moment, that's coded to use the test users, and we need to change that to use ASP.NET Identity. So let's make a start. So firstly, we need to install the ASP.NET identity support for Duende IdentityServer. So we can install duende.identityserver.asp.NET identity. So we can add that. And then in my code, I want to create a DB context. So I'm going to add a new directory called database. In here, we'll add a new file, which will be a C# class called application DB context. And we'll have this derived from identity DB context. And we do that as this gives us a little more flexibility as we have our own DB context rather than relying on a predefined DB context. So in here, I want to define a constructor. And this constructor will take a DB context options. The options is typed and is typed on this DB context. We'll just call this options. And then from here, I'm going to call the base class constructor passing up that options. So to use this back in program.cs, I need to add that DB context to the services. So up here, we can call builder.services.addDBContext. We give it the type of the DB context, which is our application DB context. And again, this takes a lambda, and that lambda takes an options. And we know what these options are now. In here, we have to configure SQLite and specify the assembly for the migrations. So essentially, we have the same configuration as we had for the configuration store and for the operational store. So once we've added the DB context, we now need to add identity to the application. And we do that by adding it to the services. So I can say builder.services.addIdentity. And this takes two type parameters. It takes the type that will represent the user, and that will be identity user, and the type that will represent the row, and that will be identity row. We also need to let identity know which DB context will be used for entity framework. And to do that, we call add entity framework stores. And we pass it the type of the DB context, which will be application DB context. So we've added identity to the application, but we now need to let identity server know that it should be using identity. So down here, instead of calling add test users, we'll call add ASP.NET identity. And this takes the type parameter, and this is the type that represents the user. And so that is identity user. So once we have that, we can now generate the migrations for ASP.NET identity. And remember, we're using the application DB context. And we can now see those migrations in our project. So we can run the migrations to add the identity tables to the database. And remember, we're using the application DB context for this. So then we need to add the users to the database. See here inside CData, I have a method called ensureUsers. And this method adds two users, one called Alice and one called Bob. And notice we've updated the passwords here. So they both have the same password, and that's pass123$. So if I reseed the database, sure enough at the end here, we can see that it's created Alice and Bob. Okay, so now that we've created the database and we've added the data to it, we need to update our quick start code. At the moment, the quick start code uses the test users. And we need to update that so that it uses ASP.NET identity. And there are a couple of places that we have to do this. So first of all, if we go into Pages and Account, Login, and the code behind for index.cshtml, in here we can see it uses the test user store. So let me get rid of that line, and also let me get rid of this value here inside the constructor, and also the line here where we assign to that store. So instead of that, we are going to use something from ASP.NET identity called the sign-in manager. And this takes a type, and this is the user type that ASP.NET identity expects. And that, of course, is our identity user. And we'll call this sign-in manager, and we'll assign this to a local variable. And then we have some red on the screen. So down here at the moment, we call users.validateCredentials, and that's using the old user store. Instead here we want to say var user equals underscore sign-in manager dot user manager dot find by name async. So does this user exist? And to this, we've got to pass it the username, and that's input.username. We then replace this check here to say something like this. So if user is not equal to null, and we want to await here. So I'm going to say await underscore sign-in manager dot check password sign-in async. To this, we pass the user, and we pass the password that's been typed in. So that's going to be input.password. And then there's a flag which says, should we lock them out if they fail? And we pass that as false here. If that succeeds, so we get a sign-in result of success, I also want to make sure I await on this call as well to make sure we get back a user. I can now delete this line once we've created the user above. Here we change username with a lowercase n to be username with an uppercase N. Subject ID becomes ID, and again username here becomes username. Similarly here we change subject ID to be ID, and similarly here we change username to be uppercase. So this is the standard login where somebody comes to our screen and enters their username and password. Users can also do an external login where we use a third-party provider, for example Google, to do the authentication. In this case, we want to change the callback CS.html in the external login folder. So in here, again, it takes a test user store, so we can get rid of that. We can get rid of it in the constructor parameter, and we can get rid of it here where we assign to that value. And instead, we need to inject something called the user manager. So here, I'm going to say user manager. Again, this is typed, and it's typed on the type of user. That'll be identity user, and I'll call this user manager. And again, I want to assign this to a local variable. And then we can fix up the rest of these errors. So first of all, here, what we call find by external provider, we need to replace this with a call to our user manager. So I'm going to await on a call to user manager dot find by login async. And to find by login async, we pass the provider that was created above and the provider user ID that comes from the claim. And then here, rather than calling auto provision user, we need to make two calls. We first of all create a user. So we're going to say new identity user. Remember, this is the type that we're using. And this new identity user, we're just going to generate a GUID as its user ID. So I say GUID.newGUID.toString. Once I have that user, I can then create the user within our database. So I can say await on user manager dot create async, passing it the user object we created on the previous line, and then another await on user manager dot add login async. And to add login async, we pass the user and then a new user login info. And to user login info, we pass the provider, we pass the provider user ID, and we pass the display name for the provider, which again, we just pass as the provider. So once we've done that, we can then create a new identity server user. For that, we use the ID from the user, not the subject ID, and the username again, but spelled differently. And then here where we call raise async, same thing. We need to change the subject ID to be ID and the username to be username. Both the applications are running. So I'm running the Weather API application and the Weather MVC application. So if I go to a browser window here and browse to the weather site, then it asks me to authenticate. Remember, I have a user called Alice, and the password now is pass123$. If I log in, then sure enough, it takes me to the page. So now, rather than using in-memory stores, we're using Entity Framework for everything that Identity Server needs and for our users. So I hope you found this demo useful, and you can find the code here. It's on github.com, Kevin R. Jones, and then setting up Duende Identity Server with Entity Framework. Thank you.